particle moves in a straight line with uniform acceleration. Its velocity at time t is equal to 0 is v1 and at time t is equal to t is v2. The average velocity of the particle in this time interval is v1 plus v2 by 2. Is this correct? Substantiate your answer. ఒక కణం ఒక సరళరేఖ వెంబడి సమతోలనంతో ఉంది. t is equal to 0 వద్ద కణ వేగం v1, t is equal to t వద్ద కణ వేగం v2. ఆ కణం సగటు వేగం ఈ కాల వ్యవధిలో v1 plus v2 అని తెలిపితే అది సరైనదేనా? ఈ సమాధానానికి తగిన వివరణ ఇవ్వండి. Consider a particle's initial velocity is v1 at the time t is equal to 0. Consider a particle is at A. At A, its velocity, initial velocity is v1 at the time t is equal to 0. After some time t is equal to t, it reaches a point B. At P, the velocity of the particle is v2. The acceleration of the body of the particle is constant. In the journey, the acceleration is equal to constant. T is equal to 0 కాలం వద్ద ఒక కణం యొక్క వేగం v1. t కాలం తర్వాత దాని వేగం v2. ఈ కణము సమతలంతో ప్రయాణించింది. We know that answer. Yes. The particle moves in a straight line with uniform acceleration, its velocity. Yes. It is correct. This is correct statement. We know that S is equal to ut plus half at square. Second equation of motion. S is equal to, S means displacement to, U means initial velocity, time taken to the journey, A means uniform acceleration. S is equal to U, initial velocity v1, t, time taken from A to B is t, difference t, plus half, A means acceleration t, final velocity minus initial velocity by time into t square. Acceleration is equal to change in velocity, final velocity minus initial velocity by time. Tithi vegam minus thodi vegam by kalam. That equal to v1t plus half v2 minus v1 into t. T cancel. That equal to v1t plus multiplying we get v2t by 2 minus v1t by 2. That equal to v1t minus v1t by 2. Simplifying we get v1t by 2 plus v2t by 2. S is equal to common t by 2 common. That means v1 plus v2 by 2 into t. In our answer, v1 plus v2 by 2 into t. That is equal to, this means displacement is equal to the average velocity into time. Displacement is equal to the average velocity into time, which is true, relation. From the velocity of an object B in a direction other than the direction of acceleration of the object. So give an example. కణం వేగ దిశ కణ త్వర దిశతో పోలిస్తే వేరుగా ఉండవచ్చు. అవును అయితే ఉదాహరణ ఇవ్వండి. అంటే వెలాసిటీ డైరెక్షన్ యాక్సిలరేషన్ డైరెక్షన్ డిఫరెంట్ గా ఉండొచ్చు, వేరు వేరు దిశల్లో ఉండొచ్చు. అయితే ఉదాహరణ ఉంది. ఆన్సర్ ఇస్ ద వెలాసిటీ ఆఫ్ an object can be in a different direction other than that of acceleration. Okay, yes, statement is correct. ఉండొచ్చు. Okay, the direction of velocity is different from direction of acceleration. వేగము త్వరము వేరు దిశలో ఉండవచ్చు. Example, when a body projected vertically upwards, the direction of velocity is upwards, whereas the direction of acceleration is downwards. In case of a body is projected vertically upwards from the ground, its velocity direction is upwards and acceleration is downwards. Acceleration direction is downwards. That means center of the earth. Direction of acceleration is towards center of the earth. Look at the tornado యొక్క దిశ. వేగం యొక్క దిశ ఊర్ధ్వ దిశలో పైకి ఉంటుంది. తర్ణం యొక్క దిశ అదో దిశలో భూమి వైపు ఉంటుంది. రెండు వ్యతిరేక దిశలో ఉంటాయి. ఫస్ట్ సెకండ్ కేస్ అదే రాశాం. When a body projected vertically upwards, the direction of velocity is upwards, whereas the direction of acceleration is downwards. నేరుగా పైకి విసిన వస్తువు వేగం ఊర్ధ్వ దిశలో ఉండును మరియు త్వరణం అదో దిశలో ఉంటుంది. త్వరణం అదే దిశలో. సెకండ్ కేస్, in case of oblique projectile motion, velocity is always tangential to the path followed by the part B, whereas the gravitational acceleration is always downwards. Once again, in case of oblique projectile motion, velocity is always tangential to the path followed by the particle, whereas the gravitational acceleration is always downwards. If a body projected other than 90 degrees, the body travels along parabolic path due to gravitational force of attraction. At any point, the direction of velocity is tangential at that point, and the acceleration is vertically downwards. Okay, you take another point, the body reaches another point. Here the velocity direction is tangential to that point, that position, and the acceleration always downwards. That means towards center of the earth. Acceleration always downwards. Then velocity changes. Velocity direction changes. It is tangential to the path forward. ఆ బిందువు వద్ద గీసిన స్పర్శ రేఖ దిశలో వేగ దిశ ఉండను. త్వరణం మాత్రము నిలువుగా కిందికి దట్ మీన్స్ అదో దిశలో ఉంటుంది. వేగం మాత్రము ఆ బిందువు వద్ద గీసిన స్పర్శ రేఖ వైపు ఉంటుంది. కాబట్టి దిశలు మాత్రం వేరువేరుగా ఉండొచ్చు. యాక్సిలరేషన్ వేగం అనేది వేరువేరు దిశల్లో ఉండొచ్చు. Our statement is correct. A ball dropped from the roof of a tall building and is simultaneously other ball is thrown horizontally with some velocity from the same roof. Which ball lands first? Explain your answer. Okay, ఒక ఎత్తైన భవనం నుంచి ఒక బంతిని జారవిడిచారు. అదే క్షణంలో అక్కడ నుంచి ఇంకో బంతిని కొంత వేగంతో క్షితిజ సమాంతరంగా విసిరారు. ఏ బంతి మొదట భూమిని చేరుతుంది? మీ సమాధానాన్ని వివరించండి. Consider a ball is dropped from the building, from the top of the building. That means its initial velocity u is equal to g. Another ball projected horizontally with some velocity means u, horizontally with some velocity. The height of the building is h. Okay. First case, or first ball for projected for dropped body. Dropped body. Jar vision we know that S is equal to ut plus half ut square. S means h here. Distance traveled by the ball is equal to S is equal to h. U initial velocity first ball U is equal to 0 into t plus half the acceleration g. In case freely falling body A is equal to g. Okay na? A is equal to g t square. Time taken from top of the building to ground. That is simplifying, you get h is equal to gt square by 2. T square is equal to 2h by g. T is equal to root of 2h by g. This is equation number 1. This is equation number 1. Here T is equal to T1. T1 means time taken by the dropped body to reach the ground. జారవిడిచిన వస్తువు భూమిని చేరడానికి పట్టే కాలం T1. ఓకేనా? Distance ప్రయాణించిన దూరం S is equal to h. Acceleration A is equal to plus g. Okay, because it's downwards, and time taken by the body to reach the ground from top of the building is T1. Okay. Next case. For horizontally projected body. For horizontally projected body. ఇది సమాంతరంగా విస్తరణ వస్తు విషయంలో we know that S is equal to again ut plus half ut square. S is equal to, S means distance traveled by the body. S is equal to h. H is equal to, h means vertical displacement. Here only write h means vertical displacement is h is equal to UA. Initial velocity along y direction is equal to 0 into t plus half A means g, t means t2 square. Time taken by the body to reach the ground from building along the parabolic path. Okay. H is equal to 0 into t. 0 means, here u means vertically, initial velocity along vertical direction. Initial velocity along vertical direction. Then 0. Again into t plus half A means g. T means t2 square here, second case. Therefore, simplifying that h is equal to g t2 square by 2. T2 square is equal to 2h by g. T2 is equal to root of 2h by g. This is equation number 2. Here from 1 and 2, T1 is equal to T2. That means two bodies reach same time. T1 is equal to T2. అంటే రెండు వస్తువులు భూమిని ఒకే కాలంలో చేస్తాయి. Hence the body, both the bodies reach the ground simultaneously. Hence both the bodies reach the ground సైమల్టేనియస్లీ. కాబట్టి రెండు వస్తువులు భూమిని ఏకాంలో చేరతాయి, ఒకేసారి భూమి ఏర్తాయి. Hence both the bodies reach the ground simultaneously.